Right now, the entire planet Mars is still rusting, slowly turning red from the inside out, and NASA has no way to stop it. It is happening this very second. As you read these words, an entire world is corroding, bleeding color into its own sky. And the smartest minds at NASA, at Caltech, at JPL, they can watch it, measure it, but they cannot explain how it started. What it means terrifies them more than they let on. But here's what nobody is telling you. Mars is the fourth rock from the sun. A frozen desert half the size of Earth, sitting over 140 million miles away. We've sent more machines there than to any other world. Rovers, orbiters, landers, and every single image they send back shows the same thing: red, rust red, a planet the color of old blood and dried iron. For centuries, we thought that was just dust, pretty, harmless. The Romans named it after their god of war because of that color, but the color isn't paint. It's chemistry. The entire surface of Mars is covered in iron oxide, rust. The exact same reaction that eats an old car in a junkyard is happening across an entire planet, and it has been for billions of years. The whole world is one slow, planetary-scale corrosion, and that should be impossible. Here on Earth, rust needs two things: iron and liquid water, lots of it. You cannot rust metal in a dry room. You need moisture, oxygen, time. Mars has the iron. Mars has had billions of years, but Mars is the driest place we have ever found. A desert so cold and so empty that liquid water boils away in seconds. So how does a bone-dry planet rust? That's the question that stopped scientists cold. Because the math doesn't work. The water that would be needed to rust Mars this deeply, that water should have left a fingerprint. Oceans, shorelines, vast wet ages lasting hundreds of millions of years. And for a long time, they couldn't find nearly enough of it. They tried to explain it away. Maybe ancient water did it fast, then vanished. Maybe it was a brief warm window long ago. But every explanation hit the same wall: there simply wasn't enough liquid water for long enough to turn an entire world red. The numbers kept coming up short. The authority on this planet, the people who built the rovers, were stumped. And here's the part they're still circling. When researchers finally ground up Martian dust and studied the rust itself, they found something that changes the timeline. The iron oxide on Mars contains water chemically locked inside the mineral called ferrihydrite. And ferrihydrite only forms in cool water, which means Mars didn't dry out slowly over a gentle warm age. It was wet, cold, and wet, and then something switched it off. Fast. But here's the strange part. It shouldn't be possible at all. The rusting didn't stop when the water left. It's still going. Right now, the thin Martian air, the frost, the trace moisture, the relentless radiation breaking molecules apart, they're all still feeding the reaction. Mars is rusting today. This world is actively oxidizing, grain by grain in real time, and there is no force in the solar system that can reverse it. You are watching a planet slowly die of corrosion, and it will not stop. And the dust carries it everywhere. Storms the size of continents lift that rust into the sky, turning the whole atmosphere butterscotch and red, coating every machine we send, jamming solar panels, ending missions. Mars doesn't just rust, it spreads the rust. It buries the very robots sent to study it under the evidence of its own decay. So what does it mean? It means Mars was once a living, wet world, and it doesn't end with Earth. It rusted. It bled out. Something stripped away its air and its oceans and left behind a corpse the color of iron. And the same sun that warms your face is the thing that helped strip Mars bare, peeling its atmosphere into space one particle at a time. We are watching the autopsy of a planet that died the way ours might. Same iron core, same young oceans, same sun. The only difference scientists can point to is that Earth kept its magnetic shield and Mars lost its. Lose the shield and you get this: a red, rusting ghost. And nobody can tell you with certainty what tipped Mars over the edge, or how long Earth's own shield holds, or whether the redness we see is a warning we don't yet know how to read. So the next time you look up and find that pale red star hanging in the dark, remember, it is not glowing, it is corroding. An entire world is rusting away in silence, and we are close enough to watch but powerless to stop it. The question scientists keep asking each other, quietly, is the one they won't say out loud in a press conference. If a planet so much like ours could rust itself into a grave, what exactly is keeping ours from doing the same?